Alright, so here we are on the multiple choice part. Use the following substance to answer questions 1 through 4. So these multiple choice problems. A weak acid with 2 protons would be the H2SO3 because it's got 2 protons, so that would be D, number 5. Strong acid, so hyperhickel high, honohickel low, H2SO4, you've got to know those. And so hickel low right here, IV is a strong acid, that's hickel low. And so that's letter D. And then list the substances in increasing order of acid strength. So my strongest acid over here on the right hand side would be the HClO3 because that's the one that is a strong acid that you memorized. And then we have a couple of other weak acids right here that have various numbers of protons. And so the one with more protons is going to be stronger because it's easier to release its proton. And then we have HSO3 minus after that. And then we have a substance that can act as an acid or a base, that's H2O. And then lastly we have a substance with negligible acidity or basicity, and that's SiH4, because it has no affinity to give away protons or get protons. Silicon, of course, is one of those elements that's in group 14. It's just like carbon, it wants to form 4 bonds with something, just like CH4, it would not want to give away a proton or get a proton at all. And then number 4 is the conjugate acid of the hydroxide ion. And so a conjugate acid is what is created when a base accepts a proton. So if this gets an H+, then it becomes H2O. And H2O, of course, is number 1 right here, letter A. Over here, use the substances to answer questions 5 through 8. So the first one is an ion of a strong base, which is the hydroxide ion right here. Conjugate base of a strong acid with negligible basicity. So first of all, we have to figure out which one of these came from a strong acid. And then it's the conjugate base, so what's left after the acid releases its proton. So the one that would form a strong acid, if I added an H to it, would have been Hibber right here, which is number 3, so letter C. List the substances in order of increasing base strength. So our strongest base would be the one that it comes from strong bases, which is OH-. And then you can see that I have 2 substances here that are related to one another with differing numbers of protons. And of course, the more protons it has, the more acidic it is. So consequently, the less protons it has, the more basic it is. So HPO4 and then the H2PO4 minus. And then we have a substance that can act as an acid or a base, that would be H2O. And then we have the substance of negligible basicity. It does not want to get a proton at all, and that's the Br- that comes from a strong acid. The strongest base on the list would be our OH- right here, which is letter E. Last part of this, use the answers below to answers number 9 through 16. Assume all are salts dissolved in water. So then you have to say whether they're going to be acidic, basic, or neutral. So you have to split them up into their ions. And then you have to ask, where did this come from? If they came from strong acid and strong base, both are going to be of negligible basicity. So this would be neutral in solution. This one right here, where did these come from? Well, this came from a strong acid, HCl, so it's going to do nothing in solution. This one right here, this one came from NH3, right? That would be the weak base, and so this could act acidic. So look where it came from. It came from NH3, and it has 1 extra proton and could release that. It did not come from a strong, so you know it's going to have to do something. If it came from a strong, like these 3 right here, assume that they're going to be neutral. Number 11, K+, came from a strong base. It's going to do nothing. SO3, 2-. This did not come from a strong, right? H2SO4 would have come from a strong. And so this would be affinity to gaining a proton right here. And so this would be slightly basic. RbClO3. So Rb, of course, came from a strong base. If you're not sure if it came from a strong base or not, of course, look on your periodic table. Remember, these guys that are in the shape of a B right here came from the strong bases because they have hydroxides connected to them. And then ClO3-, that came from HClO, which of course is a strong acid, so this would be neutral. Kf, strong base. F- would be a weak acid, K+ and F-, so this one would be negligible. The F-, of course, would have an affinity to get protons right here and become HF, and so therefore this could be basic. Li3PO4, well, lithium, of course, came from a strong base, right here, lithium. And then phosphate, well, I didn't memorize that as a strong acid at all, and so that means that could act basic. It would have an affinity to get protons. Br2, both came from a strong base, and HBr was a strong acid, so this would be nothing, neutral. And then this one right here, the NO3-, that came from a strong acid, and this right here, CH3NH3, positive, that would have one extra hydrogen in its amine form right here, and so it could give one away, so this would be acidic. All right, those are the multiple choice.